Now, as a follow-up to yesterday's video, go ahead and check that out if you haven't already, on cryptography that I did, talking about, is it important? You know, how important is it? How far in depth do you really need to go in order to become a pen tester? In this video, we are going to actually start learning some cryptography and diving into some of the more technical aspects of cryptography. Nothing too crazy. There won't be any like insane math or anything like that going on in this video, but I have here in front of me a very useful room on TryHackMe, and definitely a resource I'd recommend checking out if you haven't already. And so without further ado, let's jump right into it. So encryption, crypto 101. So specifically, we're talking about encryption. Now, not to mislead you guys, in the last video, there's more to cryptography than just encryption. I was mostly speaking on encryption, but there's other things that are at least important to understand what they are. You know, things like hashing and even encoding. You want to understand what the differences between encryption, hashing, and encoding are. When would you use one over the other and things like that. But specifically in this video, let's really dive into encryption, which is, when a lot of people think of cryptography, is what they usually think of here. I agree not to complain too much about how heavy theory this room is. Yeah, that is one thing that can be pretty off-putting to a lot of beginners, really intimidating to a lot of beginners. But that's why we're creating this walkthrough here. So are SSH keys protected with a passphrase or a password? They're actually protected with a passphrase. So why is encryption so important? And so essentially, I'm not going to read all this word for word here. Feel free to do the room to do that, because I think it'll be more valuable if I just kind of commentate over this. So obviously you want to make sure that your data is secured and that no one can man in the middle of your connection and read sensitive data they shouldn't be able to read. That's one usage. Another one is protecting data at rest, right? So if you have a database that's storing, you know, passwords and stuff like that, or social security numbers or whatever, you want to make sure that that is being encrypted so that unauthorized users can't just access them and read them in plain text. Also, you don't want them to be stored in log files and things like that. So now the next question is, what does SSH stand for? That's the secure shell. And how do web servers prove their identity? They do that through the use of a certificate. It's probably something he explains here. If you ever went on to a website that either did not have a certificate or did not have a trusted certificate, you might be familiar with that warning where you have to say, proceed unsafe, but I want to proceed anyways. That's usually an issue with the certificate on the site. And that's, like it says here, to prove the identity of the website. Now, what is the main set of standards you need to comply with if you store or process payment details? That would be PCI DSS. A lot of companies have to undergo PCI compliance. So as a pen tester, sometimes you get pulled in on those audits to make sure that they're meeting all of the requirements there. Now, here's some crucial crypto maths. These are not, it doesn't go into very confusing math, so don't get too intimidated by this section here. It says there's a bit of math that comes up relatively often in cryptography. The modulo operator. A lot of you programmers that are watching right now, you are probably already familiar with this. Yeah, here it says that every programming language implements this pretty much. The way you can think of modulo is that if I divide something by a number, what is my remainder? So for something that divides nicely, like 25 divided by 5, there is no remainder. Therefore, the modulo is 0. But if I divide, say, 23 by 6, there's a remainder of 5 because 6 times 3 is 18. 23 minus 18 is 5, so the remainder is 5. Therefore, the modulo is 5. So that's what the modulo is. Just think of it as, what is the remainder after I divide this number? So for this one, what is 30 modulo 5 would be 0. And then 25 modulo 7 would be, if I divide 25 by 7, the closest I could come is, 21. So the modulo would be 4. And then for this one, let's just go ahead and use a calculator. And for this one, let me just go ahead and use a calculator on this. 9091, enter 3565. Cool. Now let's go into the types of encryption. Symmetric and asymmetric. Symmetric, straightforward, just use the same key to encrypt as decrypt. And for asymmetric, it uses a pair of keys, and you have what is called a public and private key. You've probably heard of this before. The public key is the one you want to share with anyone who you want to communicate with. So it's not, if someone gets your public key, it's no problem. You actually want them to if you want to communicate with them. But you don't want anyone to get your private key. So that's something you always keep private. That's why we call it the private key, right? So the way it works, and this is a very common interview question, is which one is used to encrypt and which one is used to decrypt. Understand that you encrypt with your private key and you decrypt with the public key. Makes sense, right? That's why you give people your public key, so that they can decrypt your message. Touching on the algorithms a bit, the most standard one you'll see are RSA and elliptic curve cryptography when it comes to asymmetric. And when it comes to symmetric, AES is the standard. 128 and 256 bit are the most common. DES is something you might see, but it's broken, right? It's a weak algorithm. So if you see that on a pen test, you definitely want to be reporting that. And RSA typically uses 2048 to 4096 bit keys. And now another thing that it mentions here is that asymmetric tends to be slower and uses larger keys, but it is a little bit more secure because there's two keys involved. Whereas with symmetric, if someone gets that singular key, the entire system is broken, basically. I mean, same thing if someone gets your private key, it's really dire, but with the symmetric encryption, there's a little bit higher risk for that happening because you're both using that same key, if you understand what I'm saying. So from a security perspective, yes, asymmetric is more secure, but the problem is it's slow, and symmetric encryption is significantly faster. Therefore, a lot of times in the real world, you see a combination of both of these systems being used. So should you trust DES? Definitely not. What was the result of the attempt to make DES more secure so that it could be used for longer? I believe that was triple DES, if I remember from college, but they probably say it somewhere in the article. Oh, yeah, I was right. Is it okay to share your public key? Yes, you want to. All right. RSA, that stands for Rivis Shamir Adelman. And here is a little bit of details on the math. Based on the mathematically difficult problem of working out the factors of a large number, very quick to multiply two prime numbers together, like 17 and 23. But it's quite difficult to work out what two prime numbers multiply to make that number. So that is the whole idea behind it. Here is the attacking side. So the math behind RSA seems to come up relatively often in CTFs, normally requiring you to calculate variables or break some encryption based on them. The wiki page seems complicated at first, but it will give you almost all the information you need in order to complete challenges. So let's see. Some excellent tools for defeating RSA challenges in CTFs. And this is a personal favorite. Let's go ahead and take a look at this repo here. RSA CTF tool. RSA multi-attacks tool. Uncipher data from weak public key and try to recover private key. Automatic selection of best attack for given public key. Interesting. I haven't personally played around with this, and to be completely honest with you guys, I haven't done too many cryptography heavy CTFs either, so this will be pretty interesting. Let's see here. And here's another tool that he recommends. Cool. So here's the variables here. Key variables you need to know about RSA and CTFs are P, Q, M, E, D, and C. P and Q are large prime numbers. N is the product of P and Q. And if you haven't taken mathematics in a while, all it means is that when you multiply P and Q together, you get N. The public key is N and E. The private key is N and D. M is used to represent the message. In plain text, C is the ciphertext. So crypto CTF challenges often present you with a set of values, and you need to break the encryption and decrypt a message to retrieve the flag. There's a lot more maths to RSA, and it gets quite complicated, as I was saying earlier. If you want to learn the maths behind it, recommend this blog post. We're not going to dive into this too much, but just to take a quick glance at it. This is going to go a lot further in depth. So they give us the value of P and the value of Q. What is N? So N is the product of P and Q. So let's just multiply those two together. And let me just copy this. This is a pretty huge number. Boom. I understand enough about RSA to move on, and I know where to look for more if I want to. And I really like the way they're structuring this, because a lot of people, you know, they look at all this stuff here. Maybe they take a look at some of these things and they get super intimidated. They get super discouraged. And the reality is that these are like extra things. This is like, most people have not done crypto CTFs. I haven't done many crypto CTFs, to be honest with you. It's something you can do, and there's definitely value in doing it, but don't think that you have to learn all this super complex stuff before moving on. We got into this conversation, pretty thoughtful discussion down in the comment sections on one of my recent videos, but just understand what I'm doing here with this channel, right? I'm not gatekeeping you whatsoever. I'm not saying like, oh, you have to learn all this advanced cryptography and you have to learn all this advanced web pen testing and advanced network pen testing, or you can never get a job in this field. What I'm saying is you need to understand the basics. Very simply, the things that we're learning in this video, you want to understand in a number of the key areas that I'm highlighting for you in these videos. And if you can do that, you're going to be able to do just fine on an interview. And there might be some knowledge that you're lacking, some information. Maybe you go into an interview and even though you say you studied web pen testing, they asked you a particular question about a web vulnerability that you haven't covered yet. Okay, great. That's awesome feedback. Now, you know, even though you might not have gotten the job, now you know where you can focus next, and you just go and learn that thing on an as-needed basis. This is something I've been talking about on my channel way since the early days of the channel. Learn things on an as-needed basis. But before learning on an as-needed basis, understand the basics in the key areas in network pen testing, web pen testing, Active Directory, and a little bit of cryptography as we're doing here. But yeah, just a little rant there. Something that recently came up, and it was a very valid question by one of our longtime viewers, and I just wanted to clear the air on that. So that's how I'd recommend going through this stuff, and I'm glad they are keeping to that format in TryHackMe, which is another reason that I think this is such a great resource. So establishing keys using asymmetric cryptography. Like I said, there's normally this hybrid implementation where you're seeing both asymmetric and symmetric being used together. And particularly the way they normally use it is to use asymmetric cryptography for exchanging the keys for then using the symmetric encryption, because you want to actually do the encryption and decryption with symmetric because it's way faster than asymmetric, but asymmetric is more secure. So what you do is you actually exchange, you set up the key exchange using asymmetric, and then actually do the symmetric for the data encryption and decryption. And here we go. Here's another blog post that they reference for digital signatures. So the digital signature part is the asymmetric part. And this is actually exactly what HTTPS does. This is how it works. So you can read all about the fine details of the implementation here. And this is very much worth reading through because this is also a pretty common interview question as well. And if you want to see some more interview questions that are very common, go ahead and check out the description below for the top 10 pen testing interview questions that you need to know. I actually cover a lot of these in that article as well as many more. So I definitely recommend that for those of you looking for interviewing tips. But yeah, just understanding how this is used is all we need for this section. Now we go into the digital signature. And the point of that is to prove authenticity of the files. So like I was saying, that's the asymmetric part. It'll produce that. You verify with your public key, and then They should have the same value, same signature. Simplest form is encrypting the document with your private key. And if you want someone to verify the signature, they would just need your public key. So they can decrypt it, make sure they match, and then they know that you are who you say you are. They link the same article once again. So yeah, if they're linking it multiple times, probably pretty useful. So definitely something to check out, I would say. Who is TryHackMe's HTTPS certificate issued by? Well, if we click this little lockbox icon here, we can see information on that. Certificate is valid. Let's see. Issued by E1. I know that's really small there. Hopefully you can see. But that's how I found it. You can see this on any site, by the way. SSH authentication. So encryption and SSH authentication. So we use private keys. So you should treat your private keys like passwords. Don't share them, of course. So we're saying you share the public key, not the private key. So you could use the SSH keygen command to generate your public private key pair that you can then use to SSH. So the way you'd use it is that it would create, when you run that SSH keygen command, it will create a hidden folder called SSH. It'll have authorized key file and this is where all your public keys will go. So that all the servers that you want to be able to access this server would be in the authorized keys. And then to actually SSH, what you can do is use to SSH tac I, and this is the file, the actual private key file. And then your user that you're trying to log in as, and then the host. You can either specify an IP address or a host name. And the important thing about this key file is that they have very strict permissions for this private key file. What you want to do is run chmod 600 because it has to have very strict permissions on it. So if you don't have the correct permissions, it's going to give you an error when you run this command. This is something you could test for yourself as well. Very useful exercise to do is just set all this up with the SSH keygen command and actually set up your SSH access and try and SSH into your server. SSH keys are an excellent way to upgrade a reverse shell. Yeah, they're definitely a lot better, a lot more robust than your poor man's reverse shell, right? So assuming the user has login enabled. Yeah, so you can't SSH into, say, www.data by default because login is not enabled. But typically any regular user in the root account will have it unless they do some kind of special configuration. So leaving an SSH key and authorized keys on a box can be a useful backdoor, and you don't need to deal with any of the issues of unstabilized reverse shells like Control-C, lack of tab completion, etc. Now, also, if you get code execution on a server and the account that you're able to run commands as has read access to this SSH file, you could read the private key, potentially, of a user account and then use that to SSH into the server. They actually give you a room where you can practice this stuff even better. Oh, let's download this. Let's see. Download the SSH private key attached to this room. Download task files. I'm going to open this. We have this here. And the next question is, what algorithm does the key use? So yeah, this is using RSA. Correct the password with John the Ripper and Rock You. What is the passphrase for the key? I'm not going to crack this live at the moment because I'm recording and I've had some issues in the past with doing that. But I'll give you the command to do it. John the Ripper, very simple syntax. You can do this in Kali Linux. I'll just type John, and then I would give it the word list. So you say word list, and you need the equal sign here. And then I would pass it user share word list rocky.txt. This is where you're going to find the rocky.txt on Kali by default. And then I would say the name of the file. So it's called id rsa.id_rsa. So that's just the name of this file here. So this is the command you would run, and it would take some time, and then we would crack it. I'm going to go ahead and do that now, and I'll come back to you with the password. All right, so after cracking it, we're able to obtain password of delicious. And now we talk about the Diffie-Hellman key exchange, how that works. So key exchange allows two parties for people to establish a set of common cryptographic keys without an observer being able to get these keys. So yeah, you have to find a way to do a key exchange that is going to be secure, right? So that's where this comes into play. And generally, this is used to establish common symmetric keys, because if you don't have any kind of secured key exchange, then someone could just man in the middle and steal your key. If they steal your symmetric key, then there's no point even using encryption in the first place, right? It's compromised. So that's the point of this. Now, how does it actually work? Alice and Bob want to talk securely. They want to establish a common key so they can use symmetric cryptography, but they don't want to use key exchange with asymmetric. So this is an alternative. We covered a scenario before up here where, HTTPS will use symmetric or asymmetric to do this, but you can also use Diffie-Hellman key exchange. This is another way to do it. Here's our scenario. Alice and Bob both have secrets they can generate. We'll call these A and B. They have some common material that's public, and we'll call C. And the assumptions we need to make is that, so first, when we combine secrets / material, it's impossible to, or very, very difficult to separate, right? That's what makes it secure. Secondly, the order they're combined in doesn't matter. So Alice and Bob will combine their secrets with the common material that inform AC and BC. They will send these to each other and combine that with their secrets to form two identical keys, both ABC. Now we can use this to communicate. So that's how it works. Let's see. Is this the video I think it is? This might be the video that I watched. Yep, this is the video that I watched way back in the day. This is one from 2017. I probably watched this in 2017. But these computer file videos are pretty good when it comes to explaining encryption and stuff like that. So if you were a little confused about the stuff we covered here, definitely I would recommend checking this video out. Pretty solid. We'll just continue on for now. And so the next thing is that, what is PGP? What is GPG and AES? So for GPG, these are pretty good privacy. These are pretty solid pieces of software here. So PGP stands for pretty good privacy, software that implements encryption for encrypting files, performing digital signing, and more. GPG is GNU PG, open source implementation of PGP from the GNU project. These are just ways that you can actually use all this stuff. These are software built with all this in mind. So for AES, sometimes called, I'm not even going to try to pronounce that after its creator, stands for Advanced Encryption Standard. It was a replacement for DES, which was shorter keys and had cryptographic flaws. So they both operate on blocks of data of a fixed size. And AES, a little bit more complicated to explain, but here's a video from Computer File as well. This should help break it down for you. The last part is try some GPG, download the archive. So we're here in Kali, and I've transferred the zip file to the desktop. So let's just start by unzipping it. And that extracted and inflated this. You see it here in our current directory. So now all we need to do, and we should have GPG by default. Let's just check. We do. So we can just simply run GPG tac import tryhackme.key. And that created all of the stuff we need, all the files to then go ahead and decipher this message here. So GPG message.gpg. The part that can be a little confusing about this then is you don't actually see the key here. They actually created a file. So if I do an ls here, I see this message here, which is just some ASCII text. So we cat message, and from there we see the actual secret word, pineapple. So just copy that and submit it. And there we go. Now the final room here is just talking a bit about quantum computers. And quantum computers, it could present a problem. It probably will be a problem for encryption because it'll just be so much faster. And that is what makes a lot of these algorithms secure or considered to be secure. Because with infinite amount of time, any algorithm can be hacked. It can be, all these encryption schemes can be broken, but it's just that with our current computing power, it would take so many years, hundreds or even thousands of years to crack the encryption that we, by all intents and purposes, we consider it to be secure. Now, if there was a huge leap in computing power, as there would be with quantum computing, then instead of taking 100 or 1,000 years to crack some of these algorithms, it would take, a day or, significantly less time, let's just say, to the point that we could no longer consider a lot of these algorithms to be secure. So they're already kind of strategizing, like, what do we do to future-proof ourselves from this problem? Here it talks about specifically how quickly you can break it and things like that. Now, the NSA is recommending to use RSA 3072 for better asymmetric encryption, AES 256 for better symmetric. Now, there's a lot of competitions that are going on right now. And this is still kind of in research and development phase. They're trying to figure out what do we do. So pretty interesting. And they even provide an article to learn a little bit more on this. Looks like a technical document put out by, I think, is it the, NIST. So yeah, this is something you can dive into if you really want to go on the cutting edge rabbit hole for this stuff. But that should be all for now. So I know this was a long video, but if you watch to the end, you pretty much learned all you need to know when it comes to encryption before your first job. So congratulations, completely for free on YouTube. You learned all that information. And to be honest, the best feedback is the ones that you will get from your actual experience out there. So if you start applying to jobs and certain questions come up in the interview that maybe they weren't in this video, or maybe they weren't something that you studied or learned before, well, that can be a great way to guide you into what to learn next. So learn that on an as-need basis. Keep on trucking along, keep on compounding upon your knowledge, and soon people are going to look at you as the expert in the field, and they're going to be asking you, how did you get into cybersecurity, and how can I do it too? So hopefully this is motivating and informational for you guys as well. If you've watched to the end, be sure to comment down below with what you would like to see next on this channel. I get great suggestions for you guys. If you want to dive into some more technical content, I have that on the screen for you right now as well. I'll see you guys right over in those videos. Thanks for watching.